Hi, in this lecture I'd like to talk a little bit about the different kinds of multi-rotor drones that are available or that you can build yourself. Multi-rotor drones are drones that depend on multiple propellers to allow them to fly and maneuver, turn, go forwards, gain altitude, etc. The great thing about multi-rotor drones is that they don't have any control surfaces at all, unlike a plane where a plane has, for example, a rudder or flaps or canards and things of that sort in order to maneuver them in space. A quadcopter, for example, or a hexacopter or any type of multi-rotor copter doesn't have any control surfaces. All of its movement and direction is controlled by the way and the speed by which the propellers are moving. And there are many different kinds of multi-rotor drones. So in a quadcopter like the one that we'll be building, we have the flight controller that sits somewhere in the middle of the frame to control the rotational direction and speed of each one of the motors and the propellers that those motors are attached to. So motor 1 and 2 must move in a counterclockwise motion, and then propellers 3 and 4 in a clockwise motion. If I move the quadcopter like this, then you can see the propellers 1 and 3, the way that they move is inwards towards the frame of the quadcopter. And similarly, if I move that the schematic around like that, you can see that propellers 2 and 4 also move forwards towards the inside. I should actually mark that with my marker. So you've got that kind of motion and that kind of motion on either side. And this is what keeps the flight stable. It's the fact that the motors and the propellers are moving inwards towards the frame. That provides stability. Now, imagine what happens if you want to move your quadcopter in a particular direction. Say, for example, that you'd like your quadcopter to move towards the left. So in that case, you would want to get the number 1 propeller to increase its speed in order to increase its thrust, and that would cause your quadcopter to move like that towards the left. If you wanted to get your quadcopter to bank towards the right, then you need to increase the rotational speed of the second propeller, propeller number 2, which is moving counterclockwise. So then your quadcopter would bank towards the right. So similarly, if you want your quadcopter to speed up again, to pick up speed, then what you do is you increase the speed of number 4 propeller, and that would cause the quadcopter to bank forward, and that would push it forwards as well. And if you wanted your quadcopter to reverse, then you can probably guess you want to increase the rotational speed of propeller number 3. That would lift the front of the quadcopter like that, and then the thrust would push it backwards. Now here's a question for you. What should you do, or what should the flight controller do in order to get the quadcopter to increase its altitude? What kind of instructions should it send to the motors? All right, I'm sure you guessed it. The correct instruction here is to increase the rotational speed of all of the motors, and that will create more thrust, and that would lift the quadcopter upwards. And you can probably guess what you should do if you wanted to land your quadcopter, right? So you decrease the rotational speed of all of the motors in a similar manner, and that would get your quadcopter to land. So there you go, without having any complicated components, any motors controlling control surfaces like a rudder, for example, that you have in a normal plane, you can control the flight of a quadcopter just by changing the rotational speed of the motors and the propellers that they control. This is a great advantage for quadcopters in particular and for drones in general, and this is one reason of why they've become so popular. There are other kinds of configurations for the motors as well when it comes to multicopter drones, and I'd like to talk about a few of them here. So another alternative configuration is to still use a 4-motor configuration, but instead of having the motors in a plus configuration, to have them in a X-like configuration. So the thing that we've done here is that we've rotated the two axes by 45 degrees, and that gives us the X style of quadcopter. But again, the rest of the configuration and the way by which the motors operate is identical to the plus style configuration. You can see here that just like in the plus configuration, in the X configuration we'll still have motors 1 and 2 rotating counterclockwise, and 3 and 4 rotating in a clockwise manner. And the way by which you control now the various moves or the flight of the quadcopter has to be adjusted slightly. So for example, now if you would like to get your drone to move forwards like this, then you need to increase the rotational speed of motors 2 and 4, and that will create thrust at the back of the drone, push the back upwards, and that would cause the quadcopter to move forwards. If you want to move your quadcopter backwards, then you can see that you need to increase the speed of motors 3 and 1, and that would lift the front and cause the quadcopter to move backwards. And similarly, if you want to get your quadcopter to bank towards the left like this, then you need to increase speed of motors 1 and 4. That would create thrust on these motors and push the quadcopter to bank towards the left, and similarly towards the right. Another thing that you can do is you can get your quadcopter to just rotate on its vertical axis like this, or like that, so clockwise or counterclockwise. And to do that, in this case, if you have the X style quadcopter, and let's say that you would like to get your quadcopter to rotate like this on its vertical axis, so clockwise, then what you do is you increase the speed of motors 3 and 4, the motors that are rotating clockwise. And because these two motors are rotating faster than the other two motors, then the whole frame, the whole drone will move clockwise. And I guess you can guess, if you want to get your quadcopter to just rotate counterclockwise, and all you've got to do is to get your flight controller to increase the speed on motors 2 and 1, which are the ones that are rotating counterclockwise. So you get that motion. There's a few other kinds of quadcopters as well that I'd like to draw for you. So for example, we've got tricopters. So tricopters are drones that only have 3 propellers, hence a tricopter. And this is the front, this is how they're going forwards, and then you need to have a balanced mode of rotation for the quadcopters like this. So for the propellers like this. So propeller number 1 is this, 2 and 3. So propeller number 1 will move in a counterclockwise motion, propeller 2 and propeller 3 in a clockwise motion. These are very difficult to put together, and the software needed and the ability to control the drone is not as easy as in a quadcopter. So I've rarely seen tricopter designs being used, so very, very rare. But they do exist. So here's a tricopter. Another one that is worth mentioning is a hexacopter in an X configuration. So imagine that you've got, let's use silver, why not? We've got a frame with 3 axes now instead of just 2 axes that we have in a quadcopter, and then we've got our rotors at the edge of every axis. So this is called a hexa X. And we have number 1, 2, 3, 4, and 5, 6 total propellers. And the way by which these propellers move is so that in combination of the propellers adjoining each other is always pointing inwards. So the way by which the rotors rotate always point inwards towards the center of the quadcopter. So number 2 and number 4 rotate like this. So number 2 will be counterclockwise, number 4 will be clockwise, so that the sum of those two movements point towards the center of the quadcopter. We've got number 5 and number 1. Also, number 5 is clockwise, number 1 is counterclockwise, so that the sum of those two motions point inwards. Similarly, on the other side, we've got number 3 and number 6, and the sum of those two point inwards as well. So this is how you gain stability in a hexa configuration like this, a configuration of a drone with 6 propellers. You can then go to octa. I'm not going to draw that, but you have octahex or an X configuration where you have an additional axis. I'm just going to draw it here actually, just so you can see how you can keep adding propellers in order to gain various flight characteristics. And then you have another 2 propellers at the 2 edges here. And that gives you an octo-X, a drone with 8 propellers. An advantage of, say, a hexacopter or an octocopter compared to a quadcopter is that you've got more motors, which means that you have more lift capacity, but you also have redundancies. So for example, if you lose 1 or even 2, in some cases even 3 of the propellers, then your drone can still operate and still fly it and at least land. But if you can imagine in a tricopter, if you lose 1 propeller, it could fly off, for example. If it's not properly attached, then the tricopter will crash. And that happens as well with a quadcopter. If a quadcopter loses one of its propellers, any one of its propellers, then it will crash because it's not going to be able for it to sustain flight. Great, so with all that said, let's move on to the next lecture where we'll do a little bit of terminology. I'd like to introduce you to the terms roll, pitch and yaw.